Hey folks, welcome back to Anish Learns to Code. Today we will solve question number 1 on LeetCode 2 sum. In this video we will first discuss the problem, the algorithm or the solution, then we will code the solution in Java. I will also add these links in the description and on the timeline below so you can skip to any section which you want. Let's get started. So this is the problem 2 sum on LeetCode. What this problem states is that we are given an array integers and we have to find an integer target and return the indices of two numbers such that they add to target. So what we are given in this problem is this. Let me just have a look. So let us say that we will be given an array. So for example, the array can be 1, 2 and 3 with the target value of, let us say, 3. So we can see that there are two numbers 1 and 2 whose sum adds up to 3. So we need to return the indices of these two numbers. So the indices are 0, 1, 2. So we need to return the indices 0, 1 for these two numbers whose sum is equal to target. We are also given some constraints in this problem. So let's have a look at the constraints. You may assume that each input would have exactly one solution. So for every array that we get, there will be exactly two numbers, exactly one pair whose sum will equal to target. So multiple pairs do not exist in the array whose sum is equal to target. We even have an example given over here. So we have 2, 7, 11, 15 and target is 9. So we can clearly see that 2 plus 7 is equal to 9. So the indices are 0 and 1, which should be the answer. Another example that we have is 3 to 4 with target 6. So 2 plus 4 is equal to 6, but 3 plus 3 is also equal to 6. So now this is something that we should see. You can return and you may not use the same element twice. So for example, let's say that we have this element 3 in our array. We cannot do 3 plus 3 equals 6 and then just simply return indices 0, 0. Whatever elements that we are using, they have to be unique elements at different indices. We cannot use the same element at the same index twice. It is possible that we have duplicate elements. For example, we have an array 2, 2, 2 with indices 0, 1, 2 and let's say the target value 4. So we can do index number 0, index number 1 such that 2 plus 2 is equal to 4. Having said that, this array, we will not receive this array because there are multiple correct answers in this array. But the problem on LeetCode clearly states that whatever array we receive will have exactly one solution. So this will actually not be a sample input. A sample input that we can receive is this 2, 2, 5 with target value 4. So now we can clearly see that 2 plus 2, index number 0, index number 1 will equal 4. So now let's discuss the solution. We can approach this problem from many solutions. The most naive, brute force way of solving this problem will be to compare pairwise every elements. If there are n elements in the array, then the number of pairs is nc2, which is equal to n minus 1 by 2 pairs. So these are the total number of distinct pairs that we can take. So we can take every two elements in the array and compare them pairwise, add them and see whether we get the target value or not. If we get the target value, we can return their indices. So the space complexity for this will be constant. So the space my pen has hanged. Excellent. The space complexity for the brute force method will be constant and the time complexity will be big O of n square because we are comparing pairwise elements. So this is the most naive solution. This is not the best solution. Now the next best solution that we can think about is we can take this array and we can sort it. So let us say that we had this input array 2, 1 and 3 and we had to find a target value of 4. If we sort this array, we get 1, 2 and 3 and then we can have two pointers. So one pointer can be the left pointer, one pointer can be the right pointer, and then we can iterate them one by one, move the left pointer and move the right pointer and arrive at two values whose sum is equal to the target value. So now the space complexity for this, let's say that we sort the array in place. So the space complexity can be constant. The time complexity for sorting will be n log n, and after sorting we will iterate the left pointer and the right pointer, and the maximum number of iterations that we can do include by both left and right pointer will be the entire array. So this is just n. So the time complexity should be n log n. So we have improved on the time complexity, which is a very good thing. But can we do better? Yes, we can. So the best possible solution for this problem will be to use a hash map or a dictionary in Python. So what we can do is we can make a map. This can be a map from value to index. My handwriting is abysmal, and apologies in advance. Okay, so what we can do is, let us say that, let me take an example from LeetCode. We have this array 2, 7, 11, 15. So we have this array 2, 7, 11, 15 with index values 0, 1, 2, 3. We can create a map mapping from value to index. So our map will be our values, which are 2, 7, 11, 15. And for every value, we will store the index. So the corresponding index is 0, 1, 2, and 3. Now we have our target value. So the target value that was given in over here was 9. We will iterate on our array one by one. So let us first arrive at 2. We are currently standing at 2. When we are standing at 2, what number do we need? What number are we looking for so that when we add that number to 2, we get 9? So that is the required number. That this number is required. This is the number that we need. If we have that number, we can add that number to 2 and we can get to 9. So the required number when we are at 2 will be 7. And we can easily think about the required number, if you're standing at any number a, will be the target number minus a. So if you're standing at 2, you need 7 because 7 plus 2 is equal to 9. If you're standing at 0, you need 9 because 9 plus 0 is equal to 9. If you're standing at minus 5, then you need 14 because 14 plus minus 5 is equal to 9. So depending on where you're standing, if where you're standing is a, the required number is target minus a, because target minus a plus a will be equal to the target. So if you can find this required number somewhere in the array, then problem is solved. Then we have our current number, we have our required number, we have both of their indices. We can just return them and that will be the answer. So the first number that we arrive is 2, and the required number, the number we are looking for, is 7. So we can just ask our map, like, hey map, does 7 exist in our array? So our map will be like, yes, it does exist. If it does exist, at what index does 7 exist? 7 exists at index number 1. So this is our answer. Our answer is index 0, where we are currently standing, 2, and index 1, where 7 is. Because when you add the elements at these indices, you get your target value 9. Okay, so this method does work. Can we prove it that this method will also work with duplicate values? I can prove that as well. So let us say that we have an array with duplicate values. So the values are 3, 2, and 5 and 2. And let us say that the target value that we're looking for is 4. The indices are 0, 1, 2, and 3. So we know that the answer should be 1, 3, because at index number 1 we have 2, at index number 3 we have 2. When you add 2 plus 2, you get target value 4. So the first thing that we do, we will create our map. So we will create a map by iterating on our array from left to right. We arrive at 3. 3 exists at index 0. Then we arrive at element number 2. 2 exists at index 1. Then we arrive at element number 5. 5 exists at index 2. Then we arrive at element number 2. So 2 is already there in the map. So we're updating the index. 2 now exists at index number 3. So you see that we have overwritten 2. We have overwritten the index 2. So now that we have created a map, we will now iterate on our array to search for the target value. So we'll start from the left. We are currently at 3. Our current value is 3. So the required value, what number do you need? We need 1. If we have 1, 3 plus 1 will be equal to 4. So does 1 exist in our map? 1 does not exist. Moving on. We are now standing at 2. What is the required value? Required value is 4 minus 2, 2. Does 2 exist in our map? We ask. Our map, does 2 exist? 2 does exist in our map. Because 2 exists in a map, we are currently standing at 2, and 2 also exists in a map. So now there are two possibilities. The two possibilities are that the index of 2 that we have received is our current index, or the index of 2 that we have received is some other index. If the index of 2 that we receive is our current index, this is not a solution, because it is clearly stated in LeetCode that you cannot use the same element twice. So if the index that we get from the map is our index where we are currently standing, this is not the solution, we move on. If the index that we receive from our map is some other index, it is not where we are currently standing, that means this is a valid solution, because these are two different elements. They may have the same value, but they're unique, two separate elements, and their sum is equal to the target value. So if the index that we get from the map is equal to current index, this is not the solution. If the index is some other index, this is the solution, and we will return this as a valid answer. Another thing that we can note is, it is possible that 2 exists multiple times in the array. So let us say that we have 2 over here, then 2 over here, 2 over here, 2. It's a very long array, and we have multiple number of 2s. So then the question arises, which pair should we return? Should we return index number 0 and 3, index number 0 and 4, index number 0 and 5? Which pair of indices should we use? The answer is, LeetCode clearly states that there will exist only one pair of valid solutions. So this case that multiple solutions might exist will never arise, and that has been promised to us by LeetCode. So we don't need to think about it. So yes, this will be the most optimized solution of approaching this problem. The space complexity for this will be big O of n, because we're creating a hash map, and the maximum number of entries that can be there in this hash map or dictionary can be the number of elements. If every element in our array that we're receiving in our function is unique, then there will be maximum n number of elements in the hash map. So this is the maximum space that can be occupied when we run our program. So the space complexity will be big O of n. The time complexity, on the other hand, first thing that we're doing is we're creating the hash map. So we're iterating once over every element of the array, and for every element of our array, we are updating the index. So when we iterate over every element, we're working for every n elements. And for every n elements, we are performing an updation operation on a hash map, which takes constant time. So the total time taken for creating the hash map will be n, because we're working once for every element in our array. After we have created our hash map, we will once again iterate on our array from left to right, searching for the required value. We will compute one required value for every element, and for every required value that we compute, we will perform one search operation in our hash map or in our dictionary. Does the required value exist? Computing the arithmetic required value for every element and computing whether that required value exists in our hash map or not is a constant operation. So once again, we're doing this for every n element. So the time complexity for this solution will be big O of n. So we have reduced the time complexity to linear time, which is excellent. We'll now move on to the solution in Java. Alright, so let me just copy this function. So this function will receive an array of nums. I'm just going to call this numbers because I think it's a better name. And we will receive an integer value target. And we need to return an integer array of length 2. So basically the first index and the second index. So let us begin. The first step that we need to do, we need to create a map. The map will be from value to index. And I need to import this name. So this will be index, this will be value to index. So let me just call it value to index. And I'll just create a function get mapping. And I'll pass my numbers in it. Once I've received this value to index map, I will then iterate on every element inside my array. So I will work for every index equal to 0, index less than array, numbers dot length. I will now compute the required value. If I'm currently standing at this element, what is the other conjugate number that I require? So that when I add both of these numbers, I can obtain the target value. So the required value will be the target value minus the current value. So this is the required value. If this required value exists in my mapping, so if my map contains this required value and this required value is present not at this index, but at some other index. So the index of this required value, like I need this other number, and this other number should not be me. This other number should be some other number, because I need two distinct numbers whose sum is equal to target. So the index at which this required number is present should not be equal to my index where I am standing. In that case, I found the answer. So if I need some required, I require some number. If that number exists, I have that number in my array, and I have that number in my array somewhere else. So it's not like I am 2 and I need 2 and there's only 1 2 in the array, which is me. So I can't, because I have to use distinct numbers. LeetCode has clearly stated that. So if I need a number, it exists in the array and it exists at some other index, then I found the answer. I can just return a new integer array. The first value is index and the second value is the index of the required number. If I have not found this, for example, this number that I need does not exist, or maybe this number does exist, but it exists at the same index. So basically this is just me. That means I have not found the answer. Do not return the answer, just move on to the next value. So keep on doing this until and unless you find the answer. And it has been guaranteed by LeetCode that the answer doesn't exist. But this is Java, so we cannot return null, we cannot return void when we have clearly stated that we will be returning an integer array. So after the for loop, I'll just return an empty integer array. So this condition will never arise because we know, like we have been guaranteed that an answer and solution to this problem will always exist. So this statement will never execute, but we have to write this because this is Java. Alright, now I will write this function get mapping. So I have a public map integer get mapping. This function will receive an array. This function internally will create a mapping from integer to integer. So this will be the result, and this will be a hash map. So now we need to iterate over our array. We need to update our hash map on every value. So we will say, we'll just simply put that this value exists at this index. So array index is simply the value. This value exists at this index. And once we have created our hash map, we have created our mapping from value to index, we can simply return it. So this is all this is the solution. Now let us simply test the solution, whether this actually works or not. Till now it's just conjecture. So let me run this code, and we are testing our solution against every sample test case. So we have 3 test cases, 1, 2, 3, and we're testing it. And it has passed all 3 sample test cases. So that's a very good sign. I will now submit and let us see. Yep. So our solution is correct. The time complexity was big O of n. The space complexity was also big O of n. Thank you very much. If you have any other solution or other approach to this problem, please leave it down in the comment section below. I would love to see what people can think differently. I would love to see what approach you take. Thank you very much. See you in the next one. Ciao.